So, who am I? I'm Aaron. I'm the CEO and co-founder of FriendCode. You can send me an email at this address, or you can follow me on FriendCode, GitHub, or Twitter. So let's proceed. Here's a bit about my Python background. I did a lot of Python these past few years. Essentially, Django about 2-3 years ago. A lot of NL, natural language processing, machine learning, scrapers, web crawlers, that kind of stuff. And nowadays at FriendCode, we use a service-oriented architecture, and we use Python for web APIs and DB logic. So we used like Tornado, those things, and we also use Gittle, of course, which is Python. And then we use a lot for tooling and various different small scripts. Okay, so why? That's a good question. Why would someone ever want to implement Git entirely in Python? Yeah, I guess like the obvious reasons is Git is awesome, Python is awesome, and I like automating things. We're building a service, and so what Gittle is basically a Pythonic library to programmatically control Git that you embed and use in your services. So I really just built it because we had this problem at FriendCode, my company. We needed to pull in repositories, push them back out, authenticate dynamically, and all that. And there was just no good libraries out there. I'll talk about alternatives at the end. I went down this path, but there's other paths I could have gone down. So, goals. No to little boilerplate, as in I want it to be very expressive. I guess most of you are familiar with Kenneth Reed's request library, which basically is HTTP for humans. Gittle is Git for humans. It's easy to use, no boilerplate. You've got high-level abstraction. You don't need to worry too much about the details. It's data-driven. So I explained briefly that we use a service-oriented architecture. That means that all our systems communicate over services, so we have to serialize the data in and out. And so I really wanted to keep the data formats simple and easy to comprehend. So each time, all the data input is just basically either something that can be serialized as JSON, so it's just integers, strings, dicts, or lists. Okay, and it's pure Python, so you can run it on PyPy and all that kind of stuff. So here, I'm not sure if everyone, who's familiar with Git in the room? Okay, pretty much everyone. Okay, well, let's just go over the basics anyway quickly, so we're all on equal footing. So a repository is basically like a project. It holds all your code source regarding a certain project, and it takes care of the versioning. You have a commit, which is basically a group of modifications, and that creates a version of your project. A remote is kind of, well, what you store on GitHub, Bitbucket, or on your personal servers. It's a remote repository so that you can collaborate with other people. A blob, they're kind of more detailed, but basically a blob is how Git stores files. We'll go into that later, because I'm going to go into the details of Git and what I learned through Gittle. A tree is kind of the way Git snapshots folder structure. So it stores all the blobs individually, and it just stores the file's content. It doesn't know its file. It doesn't store its file path with it, just the content. And then it's the tree that references the path. So SHA is basically just a hashing algorithm that Git uses internally. And so SHAs are also identifiers for all kinds of objects. We'll talk about them. Objects are blobs, trees, and commits. So like frequent actions, these are like kind of the most common ones in your workflow. You'd like to do git add, git commit, git push, git pull, clone. So yeah. Okay, I think we're all on equal footing and everyone seems to know Git. So here I'm going to go through some samples of actually real code using Gittle. As you can see, it's just very, very, very easy. This example does a few things at once, and we'll go into like the different functionalities one by one. So here we basically import the Gittle class from the Gittle module, and the Gittle class is it basically models a Git repo. And so what we do is like it's very easy. We assign the repo to this variable, and then to get a list of commits, all we do is repo.commits. If we want to get a list of branches, we do repo.branches. If we want to get a list of currently modified files, we do repo.modified files. If we want to get a diff between, for example, the head and its previous commit, we can do, well, this, repo.diff. And I guess you can kind of see here that it's really expressive. It does what I want it to do, no extra boilerplate, no extra complexity. It's simple to use and understand. there's actually extra parsing because Git doesn't understand those references, and the command line does, but it doesn't exist in the protocol. So basically, Gittle handles all that parsing for you. So you can reference the nth parent commit to this commit. Okay, so let's move forward. So cloning. How do we clone a repository? Here, well, we import Gittle like we did before, and so we have a class method on the Gittle class. So what do we do? What do we need to specify when we clone something? Two things. Where are we cloning from? Where do we want to clone it to? What do you do in Gittle? You say, where do you want to clone it to? Where are you cloning it from? Then, once again, no boilerplate, just simplicity. If you want to clone a bare repository which has no working directory structure, which is bare repositories are used for basically like centralized repositories like we talked earlier on. That's what GitHub uses when they store your repositories because they don't want working versions of your file. The working repositories are what you have when you work locally on your desktop or in other places. So to simply, for example, clone a bare repository, we can just add a bare keyword argument and set it to true. So committing is actually pretty easy as well. This is voluntarily verbose. It can actually be a lot simpler. So once again, we import Gittle. We initialize we set up our repository, and then we stage files. I guess you're familiar with stage. Stage is also aliased as add. So you can do repo.add. It's the same thing as stage. And so you can either specify one file, or you can specify a list of files, which is good. Alternatively, instead of staging, so staging will add them to the index. What you can do is basically in your commit call, add a files keyword argument with a list of files, and so that won't add them to the index. It will commit them directly. Okay, so as you can see, we've done cloning. Cloning's trivial. Committing is trivial.
All of this talk has also been happening in the room next door.
Oh.
It's not your fault.
Yep, sorry.
The guy next door has been like a little puppet on his hand. Displaying everything.
So branches. Okay. Once again, we initialize our repository. Okay, and what do we want to do? We want to create a development branch of our master branch. So what information do we need? Just the name of the branches. Okay. That's easy. And then to print out the branches, all we have to do is print repo.branches. Once again, everything's simple. We want to remove a branch, we call repo.removeBranchDev. And that's it. And we print out the branches again. So moving forward, that's branches. So diffs. Diffs are kind of like important. Diffs are actually funny because a lot of people mistakenly think that between commits, Git stores the diffs. So that's not true. Basically, when you get a diff, Git basically computes it at runtime. It would be that's one of the properties that makes Git robust and actually beautiful. Otherwise, you'd end up with SVN. So we don't want to go there. So here's a simple diff. So once again, that was actually in the first sample. So we're calculating. This can be between any reference. So we could actually put dev and master there, the branch names. So this is a diff with a working directory. So you've modified files locally, and you basically haven't committed them. Okay, and so you want to know. Okay, so what modifications have you made since the last committed? And that's what diff working does. So it basically does a diff between the commit you specify and your working directory. Okay, so Git also supports a Git TCP server. I'll talk about protocols in detail in a few slides. It's really easy to do a Git server. What you do is Git server, the folder where your Git repositories are, and then where you want to bind to. That's it. And you call serve forever. You can specify permissions. Do you want this to be read-only, write-only? I'll actually talk about the Git TCP protocol has some shortcomings. Thankfully, it's actually kind of disappearing because it's hard to factor in authentication into it. It's not as robust as SSH or HTTP that we'll actually cover in a few slides. So moving on. This is advanced Git, so we're talking about nothing. So we're going to basically talk about how Git is beautiful internally and what I learned about Git's internal structure while building Gittle. So we're going to talk about, okay, so what's the head, what are objects, what are refs? Refs are used to represent branches and tags, what's the index, and then we're briefly going to cover what are the different protocols that Git supports and how they kind of work. The protocols are kind of a big topic themselves, so I will cover them, but not in massive depth. So a head. What is a head? As it says there, the head is basically just a reference to what is your current branch. So what my repository, somehow, it's either on my master branch, my dev branch, a feature branch, and so the Git repository needs to know that. And what does it do? So actually, before continuing on this, I'd like to say about Git's global structure, there's something very, very beautiful about it. Everything's basically stored, well, most things are stored as text files compressed with zlib, but they are text files. And so it's actually really, really simple. So actually, head isn't compressed because it's just such a short file, it would be pointless. So what it does, it just contains a reference to references that we'll talk about later. And where it's located in your .git folder /head. That's for working directories. If it's a bare directory, then it will be just head. So what are objects? Basically, objects are kind of core to Git. It's everything from blobs, which are files, from trees, which are directory structures and file structures, to commits, which are modifications, scripts of modifications. So like I said earlier on, what's elegant is it uses text, but it's compressed using zlib, well, to save disk space. And as we talked about early on, a key important part of Git is also the SHA hashing function, which is used basically to identify everything and validate everything. It's used also for checksums, basically, and seeing, okay, is this the same, is it not? So, for example, here's an example, a sample SHA. So we see it like that. It's actually, so it's stored in like .git. Sorry, this actually isn't full, that's my mistake, but it's actually stored in .git/objects/fb. And actually, if you look at it, so this is just the hexadecimal representation of the SHA. And basically, the reason why it's not flat, that you have fb/ here, is kind of a technical reason. It's because on some file systems, you've got a limit of how many, child nodes a parent node can have, like so how many files a directory can have. And so basically, to avoid that limit, basically, you have less possibilities. So like they put FB here in the subdirectory, and then everything that starts with FB inside that. So if you remove the slash, you can see that it's the same. So moving on to refs. Refs are great because they're simple. All they do is basically reference SHA. They're a simple text file that contains nothing else than an SHA. So, and how are they stored? They're stored in a .git refs folder. So, for example, here's an example where I basically listed out the contents of my refs folder. And so you can see the subfolder heads, what that stores is your local branches, okay? In this case, this repository doesn't have a remote. It's not linked to a remote repository. But as I guess most of you know, remotes have names. By default, that name is origin for default remote. And so you'd actually see a ref/remote/origin in that case. So here's also tags. How many people use tags in the room? Git tags. Okay, other people, why don't you use them? No, tags are really a misunderstood and underused feature of Git, because think about it, when you're building software, at some point you build it and it comes to a certain release. Like if you're building Python, you're going to increment the version in your package. And really, wouldn't it be good if you could just jump back in Git to, okay, the state of that repository, instead of having to go through, do a git log, and then look for your commit message? That's tedious, and it's not a good workflow. Instead, what I recommend is basically adding tags using V, well, like version 1, version 2, version 3, or whatever. So these are very good references. Tags are a good thing. You should use it. Well, okay. The difference between when you should use tags and branches differently. They are very, very different. The difference between tags is that you should set them once and they should never change. They should always refer to the same thing. Whereas branches are continually evolving. That's normal. You've got a development branch, you commit to that, you commit to that. Whereas a tag, it always references a specific commit. So don't change tags, set them once and forever, and then branches evolve. That's just life. So the index. The index is basically just a simple file that what it does, it stores the current files that have been modified in your working repository. So Git knows, okay, this one has been modified, this one has been added, this one has been removed, etc. That's what it does. It's stored in .git index. As I said, only working repositories have it because obviously bare repositories don't have a working subdirectory with files, and they don't need it. So this is protocols, the fun part. Once again, I actually find that Git is kind of elegant about this. So there's kind of two main commands in all the Git protocols, and so here these names reference executables. They do in the others, but using when it's operating over SSH, it directly calls these executables. So basically, SSH, as I said, it's great because SSH has built-in authentication. We already use it all the time. RSA keys, it's solid, it's good. So whenever you're basically pushing information, what you do is that, so it can seem counterintuitive. Why are we doing git receive pack and we're pushing information? No, the git receive pack is basically called by the server. And so what it does, and why is it receive pack? It's because so it calls this program, and then this program waits for information to come in the standard out, and that's coming through the SSH protocol. It's waiting for data to come in through the standard in. No data comes in through standard out, obviously, and then it sends back data through the standard out to the caller. So that's used for pushing and anything where you're modifying a remote repository. You're modifying its contents. This is used for cloning, pulling, everything where you're fetching content from the remote Git repository. And so obviously it's Git upload pack because it's the SSH server that is uploading the contents of a pack. Packs are kind of just the package. So we talked about objects earlier on, and packs are just groups of objects. They're used to it's basically just more efficient to send them out all packed together than one by one. So, as I said, the Git protocol that operates over TCP kind of sucks. It really does because it's got no solid authentication, but it follows the same rules as the SSH protocol. So it doesn't. So SSH, you all know it because it allows you to give you a shell. So the Git protocol sends these commands differently than the SSH protocol, but it uses the same commands. Essentially, git receive pack and git upload pack. I really think it's outdated, and I hope it disappears because even on GitHub or pretty much any service, it's only supported for read-only repositories, and it's really not good. It's just that it's not a standard protocol. What's kind of nice about the SSH protocol is it's got brilliant authentication, RSA keys. There's going to be a third protocol, which is HTTP, we'll talk about. But so really, the Git protocol over TCP has all the disadvantages, none of the advantages. It's not built upon a standard protocol, so it's its own defined protocol. So it's hard to compose it. There's no special. You have to build special tooling for it. You can't just use tooling for SSH or HTTP. And I really hope it disappears. By the way, who still uses Git TCP? Okay. Like I said, it's unfortunately it's still used for read-only repositories, but it should disappear because it's pointless. There's no performance gain compared to SSH or HTTP. It's just legacy, really. Smart Git HTTP is kind of my favorite because I love HTTP, and well, obviously HTTPS. The beauty of HTTP is composable and also works everywhere. Is like the big advantage of HTTP is contrarily to SSH. SSH is the port 22 that SSH operates on is sometimes blocked by corporate firewalls or whatever, which can be a big pain when you're just on the go and you're working. So HTTP obviously is never blocked because otherwise people can browse. So that's a good thing about HTTP. Another thing is it's standard. So we've already got, when we think about it, we've already got a massive amount of tooling around HTTP. We've got web servers, we've got load balancers, HA proxy, we've got tons of reverse proxies. We've got lots and lots and lots and lots of tooling around them. So HTTP is good, and GitHub started pushing it a lot. So one of the interesting facts is it uses HTTP basic auth, which is, so the authentication in this case is nice because it's easier to modify and to put in your own custom authentication. We were talking about SSH, which is great, but the only downside to SSH is that if you're running a service like GitHub, it's annoying to do dynamic RSA key authentication. So what they've basically done is they've patched their SSH daemon to actually look up the RSA keys in their MySQL, their database instances, basically. So you have to modify the SSH daemon, which is annoying. Where in this case, you can basically just put a piece of middleware, an authentication server, which basically then just reverse proxies the connections to it. And so that's what's beautiful about the HTTP protocol. So I have actually another project called, it's Node Git HTTP. So it's actually a smart Git HTTP server node. I haven't open sourced it. I probably will soon. So I just wanted to share here, for example, this is the mapping of the URLs to the handlers. And to give you an idea of kind of how it works over HTTP, it's interesting. So everything here is git upload pack, git receive pack. You can see their post calls. So use the HTTP post. And all the rest is basically kind of exposing these objects. We talked about the objects, head, the refs. And it's kind of like, it's not serving them statically, but more or less. It's similar to that. It's about serving them statically, and then you have to insert your own content type. But I think this gives you a good grasp of how it works, more or less. So that's it for the protocols. So this is a wrap-up. Gittle is a project we started at Friendcode. We use it in production now. I hope, some of you will be inspired to use it in your own services and see, how simple it is to play with it, and then how simple it is to build things with it. One thing I should have shown in the samples is authentication, because I complained about that, but actually it's very, very, very easy to do authentication on Gittle. I'd have to go back to the sample, but basically you've got an auth method on the Gittle class, on your Gittle instance, and you just pass it 3 possible keyword arguments, one which is username, password. So password's optional. If you then put, because password can be optional, and then P key, which is your private key. I hope by going into Git's internals, most of you have understood how Git is really beautiful and elegant. It's not just some obscure protocol, and it's very robust and nice. I really like Git repositories because for me, they are the standard unit of code for a project. So it's easy to ship Git repositories around. When you think about it, what you do to deploy to Heroku, you've got your Git repository, Git push. We actually use Gittle to deploy to Heroku. At Friendcode, we build a cloud-based development environment, and so we use Gittle to do Git pushes to Heroku to deploy, and obviously we authenticate using Gittle. I really think Git and code, I think code versioning is something really extremely, extremely important. No developer should go without code versioning, and Git has really nailed code versioning. It's robust, distributed, it's adopted, it's a standard, it's everything we want and need. So what's nice is companies like GitHub and Bitbucket are pushing it. It looks like GitHub is wanting to gain adoption, wants Git to gain adoption, not only in the developer world, but potentially for people like lawyers, scientific writers, basically anyone, because code versioning is awesome. It really sucks that you've written a document in Word. Why can't you go back to previous versions? So I hope Git will rule the world. Okay, so this is demo time. So what we're going to do is, Okay. The only thing is that my shell prompt is quite long, so it's gonna. Okay, so I'm using virtual env wrapper, so I've already got an environment with Gittle. We'll just open up an IPython shell. Okay, that's not great, but we'll have to do. So what do we do? From Gittle import Gittle. So we can obviously not only tap into existing repositories, we can create repositories. So what we're going to do is we're going to create a new repository. So we're going to call gittle.init. And so we're just going to create this in temporary PyOhio. Yep. Okay. So it's returned, no errors. Let's hope it worked. It will, but okay. So let's cd into it here. So I'm going to basically use Gittle and on the side show the standard Git command line and a few other things to kind of give you a practical understanding of how what I just talked about works. So here we're in a repository, and as you can see, we sorry, yeah. So we can't see it well, but we've got a .git repository. So let's go in there. I think I can do ls1 too, but okay. Let's create a new file like you would do developing. I hope you don't use echo. Let's pipe this. Okay, so now if we do git status, what does it say? We're on the branch master. This is going to be an initial commit, and we have one untracked file. So
you're over here too.
Oh, okay, thanks. That helps. Okay, so now we're in our Python shell, and how do we display the untracked files with Gittle? Well, repo.untracked files. What do we get? A unique set of out.txt. Okay, so I told you we could commit with Gittle. I didn't lie, so let's do it. So repo.stage or add, repo.add, and so we're just going to do out.txt. Let's add that, and so repo.commit. And so let's put in our name. Let's say we're email. And then let's just put our message. So
if you run bang clear, it'll clear the whole IPython screen. There we go.
okay, but do you see that it committed? Okay. Because that's the important part. That's what I care about. Okay, so let's clear this as well. So git log. Oh, our commit's there. Funny. Hi. So it did everything we told it to. It put our name down as PyOhio. That's not my real name. Put down my email address. You can send me an email there if you want. And so put in our message. So that's pretty cool. So let's go back here. How do we do it in Gittle? So we've got a repo object again. And what about repo dot? Sorry. So we've got a repo.log method. Let's call that. And what does it give? Funny. A list of commits and their information. So here we see there's an author object, which is what's displayed up there. I don't know if you can see how this matches, but yeah. So we basically, all the information's up there. It's here. So we've got the message, we've got the description, we've got the SHA, we've got the summary, we've got the time, which is a timestamp, obviously, and the time zone, which is a time zone. So there we go. We were able to commit. It worked great and everything. So that's kind of nice. What would you like to see? Would you like to see some of Git's internals, or would you like to see more of Gittle? What about cloning? Gittle. Okay. So let's create a new so we're going to create a new repository, and this time we're going to create it remotely. So we've got our Gittle. Let's see. I'm really sorry that the screen's so small, but okay. So we've got the Gittle.clone method that we saw earlier on. How does it work? Okay, so we give it the origin URL and then the local path we want to clone it to. Yep. So we're just going to override our previous repository, and we're going to do Gittle.clone, and so origin. So we're actually going to clone. We're going to clone it from GitHub. Why not? So let's do HTTPS. By the way, obviously all the source code is public on GitHub. You can use it. So this is the URL. So let's clone it to temp Gittle. And for let's see. Oh, what, oh. What did we do wrong? Sorry. Gittle. Why is there a bool object? Can anyone see what I'm not seeing? This. No, it's source and destination, and that's what I've got. Why is there a bool? Why live coding isn't always great. Let's try. Oh, I know. Sorry. I actually just made a modification to my local Git that broke cloning. That's not good on me. So, actually, let's do something. Let's fix that real time. So, so let's cd back into where I've got Gittle locally on my computer. And as I said, Git's awesome. So, there's what I did. And let's go back 2 commits. Okay, and now let's reinstall this into the thing. So, okay. Yay! It should work now. Yes. So, we've got a repo. Okay, we need to import Gittle again. Obvious. So let's import Gittle. Clear the screen. Can everyone see? Yep. Better now. So let's import our repo. Yep, and it's cloning. So it's worked. So let's cd on our terminal into Gittle. Okay, and we've got our folder. So let's do git log. And what do we have? We actually have the old commits because I pushed those, as you can see, once we reverse. So there's our clone. Even over the terrible TCP protocol, it worked. So there's git clone for you. Well, there's Gittle clone for you. So one thing I'd like to go into, so I told you how Gittle, well, no, Git is elegant. Gittle is too, hopefully. And so how things are stored internally. Let's just go at that with the command line quickly. So let's go into our cd.git folder. So ls, what do we have here? We've got that. So git log. So let's just grab the commit, or last commit. I don't know if this is the full thing. Hopefully it is. So lsc2. Okay, so ls objects c2. Okay. Okay, in this case, actually, since I just cloned the repository, they're packed. But let's go back to the one we created earlier on, the PyOhio one, and I'll just show you some of the, because basically packed packed objects aren't really that interesting. They're just a group of objects. So let's go back into this. Let's go here. And so let's do a git log. So our commit was 33do. So what happens if we do basically a cat of objects 33 and do? Okay, it's kind of rubbish because it's compressed with zlib. So I wrote a small Python script that just basically does a zlib deflate. I've named it deflate.sh. It's actually, so what we're going to do is we're going to do our cat, and we're going to pipe it to deflate.sh. So once we've done that, we get some nice text. As you can see, what does it say? It's commit, and then there's a tree identifier. And it also contains the information that we had early on from that is in git log, when git displays it, git log. Okay. So when git displays git log, it's basically pulling the information from here. That's funny. So yeah, so what it contains a few things. It generally commits, so they contain information about their tree that they refer to. As I said, a tree is a version directory structure and that points to the version files. It also contains a reference to the parent commit. Here there is no parent commit, so it doesn't contain a reference to it, obviously. It also then contains just all the kind of metadata, which is author, committer, and our description. So let's, for example, go to the tree object. You see that it starts with 7cf. So let's go here again. Cat. So I'm actually going to close the IPython shell, give us more space. Clear. So let's cat objects. Was it C2? Or 7? Yeah. Okay, we cat this again. We pipe it into our small deflate program. And what do we get? We get, I don't know if you can see this here. It says tree, and then it has the out file. See the out.txt file? So you see it's actually referring to its the name of the file. And what you see before is actually then the permissions on it, 644, which are Unix octal permissions. So yeah, so now you kind of get like, sorry, I've got a something. Okay, yeah. So you see that Git really is simple and elegant. Everything's stored in text, even though it's compressed with zlib, but that's just for saving space. So yeah, that's all for my demo. So this is the kind of like the end. So at FriendCode, we develop lots of open source components. TV.js is not really the FriendCode, but it's quite interesting. Me and my co-founder hacked it together in one day. It's basically an Apple TV that uses torrent streaming in real time. It uses the iTunes API to fetch movies for you. And so basically, you can run it on Raspberry Pi, you can run it on your Mac. Yap.js is basically, it's a modern client-side framework for building large and structured applications. We used to use Backbone, and some things were just so painful in Backbone that we wrote Yap.js. A lot of things of what we do is we really do pain-driven development. When something's pain, no, like we don't like suffering, and so when something's tedious, long, or boring, we automate it. I really recommend all of you to automate everything you can. We automate deployment infrastructure via Chef. You've got good solutions: Chef, Puppet, Ansible, Cuisine. Cuisine and Ansible are in Python. You've got SaltStack, which are in Python. So just think about automating everything. I told you Git allowed us to automate Git workflows. Automate everything you can at your startup. We're just a 2-man startup, so we had to. Anyway, so.
What does YAP stand for? Yet another painful protocol?
Yeah, how do you know? So I said we do pain-driven development, but that's not actually true. We love reinventing the wheel. So, questions? Repeat the question. The question was, what does YAP stand for? It's basically just yet another app.js. That's what it is. So it's another app.js framework. Like, we're kind of in a period where everything's hipster and cool when you add .js to it. So we're like, why not? Like, if I could call myself Aaron.js, that would be so cool. Not sure if it's legal, but I'll try. So, questions? Yes?
I have two questions. The
rent all the objects.
You mean,
And the
yep.
second question is, have you considered using Git as like a secondary database for something that's not revision control?
Okay. So the question was, does Git GC, which does that damage the pack files and interfere with Gittle? And then the second question is, can we and do we use Git for anything else besides version control? So I'm going to answer this later question first. We don't use Git for anything besides version control because we are basically, our company is all about code, and so we just use it for the most typical and boring thing, unfortunately. And then the second question, no, I've never encountered that problem. So like when I was there in the command line, when we cloned the repository, it didn't unpack the objects, but Gittle will deal fine with it. I was just in the command line there, and I wanted to show people with how using two simple commands, cat, which is a Unix command built in, and then a simple Python one-liner that deflates whatever it reads from standard in. So, yep. Other questions?
The use case for Gittle wasn't clear. Is it for kind of if you want to be frame codes?
Okay.
Method?
Yeah, okay. So Gittle is kind of comparable to Grit, which GitHub developed. And it's basically what Gittle is. It's a way to programmatically access and manage Git repositories. So basically, Gittle is what you use to run like a Git server. Let's say, so a Git server would store the Git repositories on the disk, and then it would, through some RPC service, it would expose a protocol to say, okay, clone a repository here. Okay, can I have the list of commits? Can I have the list of diffs? Can I have the list of contributors? And all that kind of stuff. So,
I mean, the API is elegant, clean, it's lovely.
mhm.
This is for embedding in an editor. I'm
Okay.
trying to figure out what sort of
Well,
automation.
okay, so it's for you're meant to use it as part of the service. So we build kind of like an online ID, if you prefer. And so we manage Git repositories, we push them to Heroku to deploy for people, we push them upstream to GitHub. So it's kind of, that's our use case. There's some people here at this conf that come from the Center of Science, and so they basically write a framework that helps basically mathematicians, scientists write documents, and they need code versioning. And so basically they're thinking about using Gittle. So I think anyone who needs to automate Git-based workflows, it's not meant for a developer. You can write a Git command line with it you want. I didn't because it's not useless. It's not useful. It's not what we want. So, yeah. Yep.
I'm there for Git Python. Do you look at that library?
So Git Python. Okay. Git Python. It does two awful things and not fun. Is that it forks the command line. The Git command line. And so one of the biggest pain that we had was basically flexible authentication. Because we import repositories from GitHub, we push them back to GitHub, we import them from Bitbucket, we push them back to Bitbucket, we push to Heroku, we support pushing to any private repositories whatsoever. So we needed flexible runtime, authentication. And so the problem with the SSH command line is it uses either the SSH agent, which is a daemon that runs locally and stores its keys, or it uses the SSH files in the .ssh folder. So you actually can do flexible authentication with the Git command line, but you have to do, the Git and then the SSH command line, but it just does a lot of dirty things. And so actually Gittle builds on top of Dulwich, which I contributed to, and Dulwich implements kind of the low-level stuff, Git pipes, and Gittle is Git porcelain, which is all the high-level stuff. And so, Dulwich had an SSH client implementation, but it sucked because it was using the SSH command line. Unfortunately, Python has a brilliant library called Paramiko, which implements the SSH protocol. So I wrote and contributed an SSH client to Dulwich using Paramiko. So it's pure Python. It's so you can use it at runtime. And another thing that's kind of annoying is that when you deploy to, for example, to Heroku, you know Heroku like outputs a log, your build log. Okay, and so I told you, I said that when you deploy to SSH, it operates over standard in and standard out. That's the way the protocol works. And like debugging information like what Heroku outputs is coming out on the standard error. And so working with the command line, it was just tedious to get like a callback to get the standard error. I could get the program finished and then get the standard error. That's no good. We couldn't build code for execution. So that sucked. So using PyOhio, I was able to kind of okay, but you get like a thread that listens, and you pass a callback function for whatever's coming out the standard error, and then the thread basically listens and grabs it and calls your callback. Okay, so, okay. No other questions? Yeah, thank you very much for your time and your attention.
We're a couple minutes before 1. You guys want to just get going early? Okay. Cool. All right. Can everyone hear me okay? Find me talking about random things on Twitter. I do a little bit of open source stuff on GitHub, and I'm one of the guys that started Work for Pi. So if you've heard of that, that was all my fault. But there's some interesting stuff there. Kind of my philosophy on take on building software. So I like to start a lot of talks with a disclaimer. I am by no means an expert at mock. So if you came here hoping to hear from somebody who knows it all, my apologies in advance. I kind of learned, well, trial by fire is probably the best way to explain how I learned how to use mock. So if you are an expert and I totally get something wrong, I'd love to be educated after the fact. So find me somewhere and let's talk. So just real quick poll here. How many of you have used mock? Okay, a few. How many of you know what mock is? How many of you have been afraid of kind of digging in and using mock? Okay, awesome. I hope to push aside some of those fears. It's confusing at first, but not as bad as you might think. So of course, before you can get started, you have to have mock, and if you're using Python 3, it's part of the standard library, so you can import it from unit test. If you're still in Python 2 like me, pip install mock is the best way to get it. So, what is mock? I pulled this, I think it's like the first sentence on the official docs, and I'm going to read it. Mock allows you to replace parts of your system under test with mock objects and make assertions about how they've been used. So, that's actually a dense description, and there's a lot of content here, so I want to highlight a couple things. You replace parts of your system. So the code that you're testing, you're actually going to, during your test, replace those with mock objects. And then the way that you do testing is that you essentially introspect those objects or make assertions on how those objects were accessed or how methods were called. So it's kind of a different way of thinking about tests. And based on a little scientific, inquiry, that is, watching people complain about using mock on Twitter, I've come to the conclusion that this is most people's typical first experience with mock. It's kind of a confusing and daunting experience. It was totally my first experience with mock. So what I want to do for the rest of this talk is just kind of show you some of the things that I do with mock. I'm going to dig into some code. But first, let's stop and talk about unit testing for a bit. How many of you do unit testing? All right, cool. So I use mock primarily within unit tests. And so kind of your quintessential unit test is you're going to exercise a piece or a unit of your code. It's often a function or a method. You call the code, you verify side effects. Maybe if it's a class, you modify some state, like you might check the attributes on a class. So I've come up with this really contrived example of something that we can unit test. So I've got this function, right? And you give it a couple of parameters and it returns a result. So a unit test might look like this. So we have a test case with a test add method. And to test our add function, we just call it. I know what parameters I'm passing in, so I know what sort of result that I should get, and I can verify that I get the right result, right? So here, I know 40 plus 2 should be 42, right? Pretty straightforward. So what if I decide that, adding things locally, that's not cool. Let's call out to a REST API, and I will, hit this API, pass out my parameters, and I use requests because that's the best way to talk HTTP. And so I'm calling an addition service. I can still test this the same way, but there's a problem. I've suddenly introduced a dependency, right? Actually, not just one dependency. My test becomes fragile because what? Because why? What's wrong with this? Any ideas? The service could be down. When I'm running tests, I have to have a connection to the network. Like if you're like me, sometimes that's not always possible. My home internet service seems to be flaky. So like running tests, when my internet goes down, suddenly breaks. So this is a good chance to use mock. So what I'll do is replace part of my code with something I can inspect. I'm going to replace requests with a mock object. And then when I call request.post, I can make assertions that method was called, that it had certain inputs, and that things were called a certain way. So let's talk about mock objects. They're flexible objects that replace other parts of your code. Mock objects are callable. You can take a mock object and access an attribute, and what happens is mock remembers that you accessed an attribute and gives you a new mock object. You can call any method on a mock object, and it will, again, give you another mock object. And mock remembers what you do. So you can make assertions about how you called things, the order in which they were called, what parameters were passed in. So let's look. Once you've got mock, you can create a mock instance. You can inspect it, and so you see that you have a mock with a particular ID. And then I can just access some arbitrary variable. And notice what happens here. I got a different mock object. So this is a totally brand new instance of a mock object. Then I could call a method, and this is just an arbitrary method with arbitrary parameters, and it gives me yet another mock instance. And then that method, I can say, assert that it was called once with this input, and if for some reason my code called this differently, this thing would raise an assertion error. So mock objects are pretty flexible. You can do a lot of things with them, and some people will use mock objects as objects in their test cases. But creating mock objects is not how I typically use mock. Mock has this function called patch. And patch is just kind of a shortcut function that says, replace this piece of my code with a mock object. So patch itself gives you mock objects. Patch also seems to be the thing that's confusing for a lot of people. So the problem is, where to patch. So let's go back to this code example where I hit this API service. I'm going to split it up into a main module and a test module. And what I really want to do is replace requests with a mock object. So how do I do that? Well, requests, when you import it, it's referenced from within the main module. And you want to patch where your code looks for something, or where it looks for an object. So what I'm going to do is typically requests will reference the request library. When I use patch, what's going to happen is that from the perspective of the main method, request is now going to point at a mock object. And so patch just kind of does this behind the scenes for you. And here's what the test looks like. So the key points are here and here. I import my add service, that's the function that I'm testing. And then I patch, and here's the part where a lot of people get tripped up. I patch the requests module, or the requests library in the main module. So main.requests. That bit of code is the where am I patching bit. So just as a show of hands, how many of you got tripped up on this the first few times you used patch? Okay, cool. So the rest of this test is pretty straightforward. Patch is interesting. It is a flexible tool. You notice that I'm using it as a context manager here. I've got some other examples where I'm using it in different ways. So as a context manager, I can get a reference to the mock object that it replaces. So with patch main.requests as mock requests. So mock requests is itself a mock instance. What I'll do is call my add service. I'll pass in some parameters. And then here's the point at which I verify that requests was called the way that I expected it to be called. So in my code, I call request.post and pass it this URL and a dictionary of data, right? So what I'm doing is I'm saying that the mock requests module was called with the post function or method, and then I'm asserting that it was only called one time and that it had these parameters, right? So if the code that I'm testing if I ever changed any of this, this test would suddenly begin to fail. So this is why I started using mock. Building work for Pi, we hit a lot of third-party APIs. And I'll admit, my first group of tests hit APIs. And so it was a pain in the butt when I lost an internet connection, or if GitHub goes down for some reason, like suddenly my entire test suite fails. And I can't deploy because, right, you run your tests before you deploy, right? And I was just kind of stuck. So I looked into mock, and solely for this reason. Get rid of network access, anything that hits the network. And then, once I kind of wrapped my head around mock, I thought, wow, this is cool. I can use it for many things. And these are a couple of the other scenarios that I really began to use mock for. One of my favorite is testing exception handler code. And so that's my next example. So assume that you've got this. Again, we're using requests, and we just hit some URL and get the JSON response, convert that back to a Python object, and wrap it in a try except block. All right? So testing this is pretty straightforward. You could test it using mock, like we just saw. But what about this bit, right? How many of you test your exception handler code? Right? If you want to get at 100% coverage, you've got to actually test this bit. So the problem is, in my tests, how do I make requests have a connection error? Or how do I force requests to have an HTTP error? Right? Mock is actually something good for this case. So what I'm going to do again is replace requests with a mock object, but I'm going to tell my mock requests object, hey, throw a connection error or throw an HTTP error. So here's the code. So I'm patching requests again, right? I get a reference to this mock requests object. I'm going to use something called a side effect. So mock has this thing called side effect. And itself is pretty flexible. There's several things you can do with it. My favorite thing to do with side effect is just assign it some sort of exception class. And what happens is anytime that I call request.get, mock's side effect will be thrown, right? So it will raise a request.http error. So this is cool. Suddenly I can control how request breaks my code, and now I can test my exception handlers. So now when I've imported my getContent function that I'm testing, and I call it, pass in the URL, pretty straightforward. And what happens is within that function, when I call request.get, it'll raise an exception. My exception handler gets tested. I can assert that request.get was called. And then I can assert that the result of calling that function gives me an empty dictionary, because that's what I decided to do in the case of a connection error or an HTTP error. How many of you use coverage? Awesome. Only there are a lot of hands that didn't get raised. So this is a talk about mock, but I just don't think I could use mock without running things through coverage. So if you don't use coverage, go check it out. Basically, the way I would run my tests is coverage run, and then whatever Python command I use to run my tests. And it will report on how, what code gets executed. So this is actually how I discovered that all my exception handler stuff was not tested. I thought, yeah, I've got great test coverage. I feel good about deploying because all my stuff is tested, and then I ran it through coverage and found out 40% coverage is not so great after all, right? So definitely check out coverage. So again, mock side effect controls side effects of calling a method. It can raise exceptions. It can also do interesting things like produce dynamic results. You can write a little function that returns an iterable, and every time you call a mock object that has an iterable side effect, it will return a new value. So I didn't put an example of this, but check out the docs. There's some great examples of how that works. So 2 scenarios: hitting third-party APIs, testing your exception handler code, and then the next thing is kind of testing expensive code. And when I say expensive, I mean, this could be memory intensive, this could be I/O intensive, this could be time. Like I might have some code that takes a long time to execute, so I can replace that with mock and just speed up my tests. So here's yet another kind of arbitrary example. So imagine I've got this scientific whiz-bang class. And it's got, the meat of this thing has this really cool, science thing that might take a little bit of time. This code is actually a little expensive if you run it. It's not quite as interesting as most scientific stuff. But so this begs the question, right? How do I test this thing? How do I test my calc alpha and calc beta methods without having to wait on the internals of this class? Right? There's no way. This was driving me crazy. I couldn't test this thing. So what I will do is replace the internals with a mock object. And the way I would do that is, again, with patch. So in this case, I'm using patch as a decorator. And not just patch. Patch has this patch.object thing, which lets you take a class and replace a method. So what I'm doing is, I've got a reference to my scientific whiz-bang class. I'm going to replace that calc method. And I'm going to specify that every time I call this mock object, it should return some predefined value. And that patched version of that method gets passed into my test as mock calc. So that way I have a reference to it. At the end of my test, I can make assertions about how it was used. So I create an instance of my scientific whiz-bang. I call my calc alpha method. And because I patched calc and I know what it returns, I can make assertions that, hey, it returned what I expected. But then I can also test that that internal method was called with specific parameters. And I'll go back a couple slides. Notice calc alpha calls this with 100 as a parameter. So that's an example of using mock to replace something that is, quote, expensive. Other things that I've done here, replace connections to Postgres. I do a lot of Django development, and sometimes I will drop down and write SQL. And rather than trying to load some fixtures and kind of figure out how to test accessing the database, I'll just completely replace that database cursor or that database connection and then make assertions on how that was used by the rest of the code. The other example are calculations or things that take computing power that might take too long. So the last class is code that needs a lot of setup. And this is kind of ambiguous. So what you can do is really customize mock objects and use them in place of other bits of your code. So think anytime you need a class that behaves a certain way, maybe an instance of that class is used as input to some method or as the internals for some method, but you can define the behavior so that it behaves the way you expect. That's not the piece of your code under test. The piece of your code under test just needs that, so I can use a mock object to replace that. So customizing mock objects, you can set attribute values or return values of a method. You can even create chains of method calls. And here's an example of something that might look like a user object. So this is another scenario. Rather than loading fixtures or creating users on the fly, I might create a mock user object. So I have this configuration dictionary. My user has a first name, a last name, and email. It also has a couple of methods, maybe a get achievement method. And notice that I can define what that method will return when called. I also set up a side effect. So, maybe when I call get age, I expect to get a value error. And I can create this mock object by just unpacking all that stuff as parameters to mock. So when I play with that object, I call m.firstname, and I actually get Alan as a result. I can call my getAchievement method and get an expected result. So I can call the getAge, and I will expect that it raises an exception. Another way to do this is with something called spec. So mock has this thing called spec, and I like to think of it as a whitelist for attributes or methods. And what happens is anything that's in the spec you can access or you can call. But anything that's not in the spec, if you call, mock will raise an attribute error. So for example, and spec can just be a list of strings as names. So again, if I was creating a user object from a spec, I have a first name, last name, email, and a method, and I can say, here mock, this is my spec, create an object that has these attributes or methods, but if I call anything that's not here, blow up. And this is really great for, I'm probably guilty of writing unit tests that also serve as regression tests at times. But this is really great for, building yourself some insurance in the future when things change. You will break your mock tests. You'll break your tests if you go changing things. So here's an instance of using a spec object. So create my spec, create a mock object. I can call get full name, and I get a mock object returned. But if I try to access something like a password that wasn't in the spec, mock says no. There's also something called an auto spec. So you can imagine that if you have a pretty complex object, typing out the spec is a bit time consuming, maybe more typing than you want. Auto spec is a tool that will introspect an object and create a spec based on what you have. So again, if I have a Django user, I can create an auto spec from a Django user with Mock's create auto spec function. So I grab an instance of a user, I pass in that instance to create auto spec, and I suddenly have a mock object that looks and acts just like a Django user object. So using mock, I create mock objects instead of loading fixtures. I create mock objects to use as parameters or arguments to other things that I'm calling in my tests. I tend to narrowly define my mock object's behavior. So if it's a user object and I know the method that I'm testing only needs access to the first name and last name, that's the only thing I'll spec. Then in my code, if I change things, I know that my tests will break. So that keeps me honest, I guess. My tests very closely test the code, what I expect the code to do. So I spend a lot of time relying on spec and auto-spec objects as objects in my tests. So tips. When I was learning mock, it probably took me about a month before I felt comfortable with it. And I read the docs. The docs are really great. But the docs they tell you kind of how to use mock. What are some scenarios. They don't really do a good job of kind of telling you the philosophy behind mock. So it kind of took me a while. Maybe I'm slow. But it took me a while to kind of wrap my head around that. But I think Mock's docs are a really great place to start. But this is the way I learned how to use Mock. So if you're not familiar with Google site-specific search, just put quotes around from Mock import and search GitHub. And you can see basically how everybody else uses Mock. So I spent a lot of time kind of digging through various existing projects, and I learned a lot just by reading other people's code. So that's it for Mock. That's what I've got so far. I've been using Mock pretty consistently now for about 6 months. So I still consider myself a novice. I really like the ability to speed up my tests. Man, it's just awesome to get rid of the I/O, get rid of the network stuff, and go through a test suite really, really quickly, which makes deploying for me a lot less painful. So I appreciate you guys for coming to this talk. Kind of went by quick. But if you have any questions, I'd be happy to attempt to answer them. Yes?
Quick question. If you're just getting started with Python development, at what point does mock come into play? Because I know there's one school of thought that says you would write the test first, then write the code so that the test passes, and only continue after that point.
So the question is, if you're just getting started with Python, at what point does mock come into play? And essentially, should you do test-driven development? I'm not quite prepared to get into that holy war. I think there are merits of doing test-driven development, but there are also scenarios where, if you're just kind of doing exploratory stuff, test-driven doesn't make a lot of sense in my opinion. As far as getting started with mock, I think if you're hitting a third-party API or a network resource, mock instantly makes really good sense. Otherwise, get comfortable using unit test or whatever other testing tools you might be exposed to first, and then come back.
All right, so mock
So mock, I think it shines when you're replacing portions of your code that access the network or have a lot of I/O or are computationally expensive, either in memory or CPU time. Thanks. Next. Yes.
I was wondering if you had any tips or patterns for dealing with sort of composing the mocking of a bunch of network requests. So for instance, we'll mock out these sort of individual requests to get data, but then we want to test the larger function that sort of does all of that stuff together.
Right.
And we've never really found a good, clean way to mock out these requests that kind of happen in sequence to a third-party API.
Okay. So the question is, how do you compose a lot of mock objects so that you can test maybe a third-party API in sequence? I'm going to say I don't know the best way to do that. However, this is probably the point at which I've abused mock, because you can create mock objects and then customize their behavior, but then on your mock object you can have yet another attribute that is itself a mock object, and you can customize its behavior. So you can build these really elaborate mock objects that essentially behave exactly like any API that you want. So I've done that, and it feels a little tedious. So there's a trade-off somewhere, and I'm not so sure that I've found it.
So rather than sort of mocking out, for example, request.post, you might mock a whole object and sort of have a post method sort of defined on that and return different values in sequence or something along the lines of that?
Potentially, but I think at that point you're getting into functional testing, and I'll admit I'm not probably the best person to talk to about the best way to do functional testing. The one thing that I have noticed is that when I really think about how I'm using mock, I realize that a lot of my methods or functions are really doing too much, and I break those into smaller components and refactor that code. And I think just using mock has made me more cognizant that it really is easier to test things and unit test these when you have really short, concise methods. And so take a step back, look at your code, make sure that your methods are small, do one thing, are easily unit testable, and then you may find that some of the elaborate mocking stuff goes away, or at least gets moved somewhere else.
With systems like that, we tend to end up writing fake backends that will actually have a project that mimics what the API we talk to. So like rather than actually bringing up the Go service backend we talk to, we'll implement in Python to implement the same API calls. We can bootstrap up and run a suite of functional tests across it. We control both ends of the code. But you're not going to mock that stuff out at a mock object by object level. That's not the right approach.
Yeah, so the comment was when you get to the point where you're creating a lot of elaborate mocks to kind of mimic an API, it's probably a better idea to step back and create a fake backend for that sort of thing.
We use HTTP pretty. They do that exact same thing when we're mocking out calls to state data.
Okay, so they use HTTP pretty, which I'm not actually familiar with. So, anyone else? Yes.
Can you example of the exceptions? There's a logging line in there as well. Do you test logging code?
So the question is, there was an example of a logging. There was. So that's a good question. I mocked logging. Yes, I did. Not in these examples. And so when you look at this test, here I would assert that, my request call, but I would also throw in my mock logger and say, yes, this thing got logged with this particular information. I've seen comments that people on the internet have said you're doing it wrong, right? You can, I don't, maybe.
How specific do you get, I guess?
Right. So again, this is kind of similar to the fake backend. You can create your own logging handler for your tests, right? And then you can inspect that somewhere else. For me, I like mock, so I thought if I don't have a lot of elaborate logging, maybe I've got like a one-off logging, just a couple of these, sure, I'll mock them. And it's not as pretty, but I've nested my context manager, so with patch main requests is mock requests, and then under with patch main.logging. Patch is really flexible. There's another thing that you can do. You can call patch in like your test startup and get a reference to this patcher object, and you can call stop and start on it. So you essentially set up your patching in your setup, keep references to those, and in your teardown, you can stop those patching. So it's kind of, not globally, but at a unit test level, you can patch a lot of different things. So I will patch requests, I'll patch logging. I've got a library that does metrics and dumps those in Redis, so I will patch that stuff so I don't have to have a local copy of Redis running to run my tests. So, good question. Yes?
Can I just make a comment on the logging thing?
Sure.
If you're using nose as your test runner, it will actually capture the logging output. So if the test fails, you actually get to see your logging.
Right.
So that is sort of, I would say, an argument for not mocking out your logging.
So, for...
Expecting to get an error, I want to assert that I added a code that adds an error log so that when some sysadmin looks at why did it blow up, he did in fact get the error log that I intentionally put in there. Then you want to test that's there. So sysadmin will get the message. So it's a valid thing.
So point and counterpoint. Nose will show you the logging error, so you don't have to test those. Counterpoint is, no, I want to test that this particular error message, happened, and my sysadmins can see, yes, this was tested. So good comments, both. Anyone else?
Can you whip and have multiple patches that you include?
Certainly, yes. So you can. Can you nest your context managers? Can you have multiple with statements here inside your test? Is that correct?
Well, can you have, yes, multiple, like in this with you have just one patch, but could you have multiple patches, like if you wanted to include a logger patch that you were checking?
So patch multiple things with one call? I don't think so, but I may be wrong.
The decorator patch is nice. You can use it in a decorator format to help patch multiple things across a method, and it's a little cleaner, and you don't run indentation way off the table.
Okay. So if you want to patch multiple things with one call to patch, use the decorator method.
Does that just add more arguments to the function?
I believe so. So the question was, essentially the question was, can you patch multiple things with one call to patch? I'd have to go read the docs again before I did that. Yeah, patch is pretty interesting. There's a lot of ways to use it, which on one hand, there should be only one, right? Next question.
So once you've mocked everything out like this, do you also do any integration testing, maybe that you run less often? So say your scientific calculation example, you probably want to run the whole calculation every once in a while. Do you do that? And then if so, where do you put those tests and how often do you do that?
So the question is, once you've mocked everything with unit tests, your integration tests, where do they go? How do you structure those, and how often do you run them? This is probably a good conversation to have with more people than me. My integration tests tend to be not all that complex, and I have mocked things in integration tests just to not hit the API, but typically it looks like when I call to this thing should happen, and it should have this side effect when I call if I'm calling multiple APIs in one object, do I get something expected, and do they interact correctly together? That's probably. I feel like I haven't answered your question, but maybe it's over my head. All right, anyone else? I think testing would probably be an awesome open space. So I would I don't remember which rooms are dedicated to open spaces, but if any of you guys want to get together and just kind of swap war stories when it comes to testing. I think that'd be kind of an awesome thing to do. We've got a few more minutes. If there's any other questions, I'd be happy to entertain those. Otherwise, we can just...
We have plenty of time, Keep rolling here.
So do you feel like you ever overmock?
Do I feel like I ever overmock things? I've looked back, and I think I'm at the point where yes, I do. And it is those scenarios where I've tried to mock up this whole API, and I've got this mock object that's mock objects within mock objects within mock objects, or where I'm doing a lot of chained method calls. So the one scenario that comes to mind is trying to mock Django's ORM, right? So I will create a mock object, and then objects.get some parameters, and maybe this is kind of getting in the realm of integration testing, where I might have a method that calls several queries, and really a view is where this happens. So like when I'm testing a view, and it maybe hits the ORM 4 or 5 times with different things, and so I try to mock that all up at once. Those mocks get pretty big. And there's maybe a little code smell there. It feels like maybe I'm putting too much effort into it. Yes?
One quick general question. Do you know of any resources for, say, for instance, covering legacy code with tests? So I can see how it would be very common where you have to test code that someone else already wrote. There's no test set up for it, and they want to, start testing it or get more consistent results.
So the question is, what's the best way to start investigating test coverage for legacy code? Coverage.py. Yes?
Also, working with legacy code by Kent Beck is really good.
Okay, working with legacy code by Kent Beck is another tip. I really like coverage. I kind of feel bad because I just recently discovered it, and it's kind of like pull the veil from off my eyes that my code is not nearly as tested as I thought it was. And because coverage so it runs your test suite within coverage, and then it knows what lines get called, and it will report on that, and it will give you this really nice HTML documentation that says, it highlights the things that don't get tested in red, so you can browse through your code and say, oh, this code is not tested. And it's pretty customizable, so you can tell it, report on just these modules or just this stuff. If I were digging into a legacy product and I knew it didn't have very good test coverage or no tests, I would start using coverage right away. So I can't remember the link, but just Google Python coverage.
A comment on that. You don't even have to run your tests. You could just launch the application using coverage, use it for a day, and see what code has it.
Okay, so that's cool. So you can use coverage to run your application, and it will... Right, and it will tell you what's getting used. That's awesome. I actually have a project that would come in handy. Thanks. Yes.
Have you mocked out built-ins? If you have, do you feel that?
So I mocked super. Yeah, the question was, have you mocked built-ins, and was that a code smell? Yes, I've mocked the dictionary object, and right off the top of my head, I can't remember why I did that, but it seemed like a good idea at the time. I did get 100% test coverage, but I did mock super, and that was probably not a good idea. But you can do it, and if you're really interested, I'll show you how I did it. There's a few quirks with mock. It's got a built-in attribute that it wants to reserve called name. Each mock wants to keep a name. So Unfortunately, I have a lot of classes that have a name attribute, and so there's a clash there. So you can actually hack mock. You can monkey patch mock itself so that you can access the name, like you take over its name variable. And that's, looking back, that's a code smell. That feels wrong. I did that too, and that's still in a bunch of my code. But yeah, mocking super. That's probably, I don't know. I don't even remember why I did it, but so yes, you can mock built-ins. All right. Anything else? Well, thank you. I appreciate you guys' attention and your time.